Question 1. The same type of lamp is used in two series circuits. The first circuit has two identical lamps, figure 1. The second circuit has three identical lamps, figure 2. The potential difference across each battery is 10 volts. The circuit on the left has a total resistance of 10 ohms. The circuit on the right has a total resistance of 15 ohms. Use the total resistance given to calculate the current through each circuit. So, we have to find the current through each circuit. Let's start with figure 1. We're going to state the given. The given to us here is first of all the voltage in this circuit, and it says here the potential difference across each battery is 10 volts. So, the voltage in both circuits is 10 volts. The V here stands for voltage, the V here stands for volts. Volts is the unit for voltage. We're also given the total resistance of the first circuit. And from this sentence here, it's 10 ohms. So, total resistance equals 10 ohms. The RT here stands for total resistance. And the symbol here is called the omega. It's the measuring unit for resistance. Now on to the required. We want to find out the required. And the question here requires us to answer the total resistance given to calculate the current through each circuit. So, the electrical current and the symbol for that is I. Now, the equation that we're going to use to solve for this question. The equation is I, or current, equals V, or voltage, divided by RT, which is total resistance. Now the solution. The solution is not our final answer. The solution is current, or I, equals 10 volts over 10 ohms. We inputted our values in the solution. And our final answer is going to be 1 ampere. The A here stands for ampere. Ampere is the measuring unit for current. Now, figure 2. We're going to do the same thing in figure 2 that we did in figure 1. And that's by stating the given. As it says from this sentence, both batteries have 10 volts. So, the amount of voltage is 10 volts. But the resistance in this circuit is 15 ohms. The total resistance is 15 ohms, not 10. So, RT equals 15 ohms. Now the required. The required is going to be the same like in the first circuit. It's going to be the electrical current. And the symbol for that is I. The equation that we're going to use to solve for this question is the same. It's I, or current, equals voltage, or V, divided by RT, or total resistance. The solution is current, or I, equals 10 volts, divided by 15 ohms. And our final answer is, we can't just find out our final answer like that, so let's use a calculator. So, 10 divided by 15. And that equals 0.66666666667. That answer is too long, so we're going to have to round it off. So, I, or current, equals 0.67 ampere. So our answer for the second current is 0.67 ampere. The current in the second circuit is 0.67 ampere.